In this video lecture, we're going to finish talking about our strings, and I want to go over how strings are compared in Python. So say that you have a string ABC, and then you have one that is, let's say, BCA. Now, because strings are a collection, so strings are a collection, and by that I mean they're technically a sequence, and for a sequence, order matters. So even though these two strings are made of the same letters, so A, B, C, and B, C, A, they're the same sort of letters, because their placement is not the same, these two are not the same strings. So if you were to try running this piece of code, if you were to do something along the lines of A is equals to XYZ, B is equals to XZY, and maybe you print out A is equals to B, this will give you a false. And that's again because even though the strings both are collections of the same letters, but because their orders are not the same, your strings are not going to be equal. So what would be equal? We could say that I have A to B X, Y, Z, and let's say I'm going to use the concatenation, the plus operator for strings to concatenate some strings together, and I can do X plus Y plus Z. So this should technically become XYZ. In that case, A compared with B is going to return. It's going to return true. So not only you can check if two strings are the same or they're not the same. So A not equals B, this will return false because A is in fact equals to B. We can also check if a string is greater than or smaller than another string. Now I know that's a bit confusing, but here's sort of how it happens. Let's say I have a string A, B, C, D, and I have another string A, B, C, E. And I am testing, so I'm going to say this is str1, this is str2, and I want to check if str1 is less than str2. Now, again, you might be thinking, how can one string be smaller, less than, or greater than another string? But here's what Python sort of, here's how Python will evaluate them. So these things are evaluated piece by piece, element by element. So first, the two A's are evaluated at index 0. Then the two letters at index 1 will be compared, then index 2, and then index 3. So at index 0, both letters are the same, so they're the same over here. They will also be the same over here. That's true. That's also true. But then, in this case, D is smaller than E because I'll go over what the ASCII code means here. But according to this table, D comes before E. So it is the case that str1 is smaller than str2. So this gives you a true. So this table is basically built up of the common keywords or single letters and numbers and symbols that can be used in on your computer and how they're encoded for your computer. So you'll have a list of the letters A, B, C's all the way down, and their decimal value. So they're all given a number. You will also have the uppercase letters and that's why lowercase a is not equals to uppercase a as strings. And you'll also have all of your numbers here, so 1, 2 all the way, and your symbols, and so every one of them is given a decimal number. And so if B, let's say, is given the ASCII code of 24, A would be 23, you'll have 25, and all the way, and so on and so forth. So in that way, when you check if the letter B is less than the letter C, what Python is doing is it's going to go back to this decimal table, this ASCII table, and say, okay, is the number 24 that is associated with the letter B smaller than or greater than the number 25 associated with the letter C? And that's why you get this to become true. Let's look at some examples in Atom. So I'm going to define two variables, string 1 to be, let's say, ABCD, and string 2 to be ABCE, and let's test a few things. I'm going to print if str1 is equals to string 2. If str1 is not equals to, the exclamation equals is not equals to str2. I'm also going to check if string 1 is less than str2, so smaller, and if string 1 is greater than string 2. Okay, so you got two trues and two falses. Because this is ABCD, ABCE, we know that they're not the same, so this will evaluate to false, that you can see. And they are not the same, so not equals will become true. Number 3 is if str1 is smaller than str2, and that is the case because in the ASCII table D, so the A's are the same, the B's are the same, the C's are the same, and then you evaluate the last one, and then you notice that D comes before E, and that's why this is true. And the last one is going to be false because string 1 is smaller than string 2. These things, string comparisons, are going to be useful when you're asking the user for input and you're specifically looking for a certain type of input. And let me comment this out for now, and let's do a very quick example where I can say user input is going to be the input function of enter a word that begins, that is cat. So I want the user to enter cat. And right now I'm aware that the user might give me the word cat, but it might be in different caps. It could be lowercase, uppercase, and to test out, to fix for that, I'm going to convert the user input to lowercase. So whatever case the user gives me, it's going to convert it into lowercase, and then I can test if user input is equals to cat, print found a cat. So if I try with dog, nothing gets printed. And now if I try with uppercase C, lowercase a, uppercase T, what Python will do is it will convert that input into lowercase first and then just evaluate here. Now, if this certain lower method wasn't there, what you would have to do is you would have to write the elongated version where you would say, okay, if user input is cat, or user input is equals to uppercase cat, or user input is equals to CA uppercase T, and you get the idea. So let's start using these methods a lot more in our assignments. Let's also talk about a special set of characters. So special characters in Python, And what they do is that they won't be printed out to you, but they're going to perform a specific task. And by that, I mean \n, which is the new line character. And whenever this is in a string and you try to print that string, instead of \n being printed to the terminal, it's going to actually start a new line. So it's like hitting the enter button, enter key. There is a T for tab character. And these are, again, important ones if you want to format a lot of text being shown to the user. And the way you'll basically use it is you'll say something on the lines of, I'm going to create a variable var, and it is going to be hello \world. Notice that I don't have any spaces here or here, and so it's going to be hello \world. And if I were to print that, if I were to print var, what's going to happen in your terminal is that you're going to have hello printed in one line and then world printed in the other. So the new world, the new line character here is just going to go away, and it's going to perform its task. So it's going to hit enter between hello and world. With the tab, it's just going to give you a longer space in the middle. So it'll be hello, then 4 spaces, and then world. But let's build up on this, and let's talk about the last thing, constructing a string using a loop. So if you remember, I mentioned earlier in the previous video that you can start off by just defining an empty string, and there's no space in here, and through a for loop, I could add things to it through concatenation. So one way of doing things is, of course, to just go, okay, var is going to be equals to, let's define x to be, let's say, ABC. So I could do var is var plus x, and what that will evaluate to is that'll just give me the previous value of var, which was blank, plus the new value of x, which is ABC, and you'll see that var turns to become ABC here. Now, I could repetitively add things to my loop here, to my var here. So instead of, let's see, I could, instead of this code here, let's do this. I say for I in the range function of 0 to, let's say, 3, var is equals to var plus x. So what's going to be happening here is that for I in range of 0 to 3, so let's make that range first going to be 0, 1, and 2, because 3 is not included here. And so for every time I becomes one of these numbers, you'll drop down a cursor, you go in that direction. Every time, for all possible values of I, add x to the previous value of var and keep building on top of that. So let's construct that here. So we start off with var to be empty, and x is currently ABC. Okay, when I in this for loop is 0, you're saying make var equals to whatever var was plus the value of x, which is ABC. So var now becomes ABC. And then you're at the end of your for loop, you're going to go back and switch the cursor to the next value when I is 1. And then you can say, okay, var is equals to, again, the current value of var plus this value of x. And so the current value of var is ABC plus another ABC, and var now becomes ABC, ABC. Cool. And then your loop is not finished yet because your cursor is not at the very end, and I will become 2, and now you're going to do the exact same thing. And so it's going to be ABC, ABC plus, so this value of var is going to be ABC, ABC. You're going to add another ABC to it, so you're going to end up with ABC repeated 3 times, basically. And so starting with an empty string, this is a very cool and easy way of appending characters or entire substrings to build up your original string. And let's look at some code here. So I'm going to define var to be empty, and then x to be our ABC here. And in a for loop, so for I in the range of 0 to 2, I'm going to say var is equals to var plus x. And after that, I'm going to print the value of var. So what should be happening is for this number of times, so range is going to have 3 numbers in here. This should be 0, 1, and 2. Oh, let me make that 3 here. 0, 1, and 2. And for 3 different times, you're going to be adding ABC to var. So you should, in fact, see ABC 3 times. Now, we could modify this a little bit. So let's say we started off with XYZ in var, and you'll notice that the original is there, but you're just adding up ABC, ABC, ABC on top of it. One way of doing this, so we know how the concatenation works. One way of doing this is to say, I'm going to go back to our example. I'm going to print out x times 3. Now, you might be wondering that we know that addition for strings works as concatenation, but times shouldn't really do anything. But what times does is it repeats a string that many times. So this multiplier becomes like a repetitor. And so instead of using a for loop to generate your string this way, you could have just used x times 3, and that would do the exact same thing. The last thing I want you guys to know is that I am also able to modify this piece of code, so this guy here, and write it as var plus equals x. This means the exact same thing. This is just a shorthand way of saying var is equals to var plus x, and it's not going to be any different. So if in the following weeks or videos you watch me doing plus equals or minus equals, don't get spooked. It's just me saying var is equals to var plus this variable. And there you have it. One final piece of information for strings is one of the functions, a new function that you're going to apply on strings. So if I have the variable ABCDE, let's say, I can use a built-in print function to print the value of that string. I can use the type function to get the type of it, but a function, not a method, so it is applicable on other type of collections too, is the length function, so len, and this will give you the length of a function of a string. So if I were to run this piece of code, it'll give me 5. Now this comes in handy because I can then use it in a for loop, and so I can go for I in range of length of variable. So if the user gave us a input which goes into var and we're not sure how big a variable is and how long my for loop will go for, so I can, instead of hard coding the value there, 0, 10, or anything, I can just pass it on the range of the length variable. So in this case, what's going to happen is it's going to give me a range of 0, 1, 2, 3, and 4. And this makes it a very useful variable way of iterating over a string without even knowing how long it is. So I can do print var of I. So give me the element at the ith index for my variable, and if you print that out, it's going to give you A, B, C, D, E. Okay, in summary, a string is a data type, but is also a collection, a sequence of characters, so order matters. Strings are iterable, so I can use them in a for loop. I can do indexing and slicing on top of them. Strings are immutable, so I'm not able to mutate an already existing string variable, and if I need to make a small modification, I'm going to have to redefine the entire variable. And finally, string has its own set of methods. We went over some, and there are new functions like the length function that can be applied on top of strings.